What are understeer and oversteer in vehicle dynamics? Imagine you're driving around a corner and the car doesn't respond quite how you expect. Sometimes it turns less than you want, and other times it swings out more than intended. These are examples of understeer and oversteer, two key ideas in vehicle handling. They tell us how a car reacts when you turn the steering wheel, especially during sharp turns or quick maneuvers. Understanding these behaviors helps drivers stay in control and engineers design safer, more predictable cars. Understeer happens when the front tires lose grip before the rear tires do. This means the car doesn't turn as sharply as you command with the steering. Instead of following the curve, it pushes wide or continues straight. You might feel like you need to turn the steering wheel more to get the car to follow the desired path. This is common in front-heavy vehicles because the front tires bear more weight and are more prone to losing traction. For example, if you try to turn quickly in a front-wheel drive car, you might notice it pushing outward instead of turning sharply. Oversteer is the opposite. It occurs when the rear tires lose grip before the front tires. This causes the back of the car to swing outward during a turn. The vehicle then turns more sharply than you intended, and if not corrected, it can spin out. Oversteer is often seen in rear-wheel drive cars or those with a lot of weight over the rear tires. For instance, if you accelerate too hard into a corner, the rear might slide out, making the car feel like it's fishtailing. Both behaviors can be measured by something called the understeer gradient. This is a number that shows how much the steering angle changes as the car experiences lateral acceleration during a turn. A positive value indicates understeer, meaning the car turns less than expected. A negative value shows oversteer, where the car turns more than intended. 0 means neutral steer, where the car responds exactly as the driver wants. The physics behind understeer and oversteer involve how weight is distributed on the tires, the grip of the tires, and the setup of the suspension. A front-heavy car tends to understeer because the front tires are more loaded and can lose grip sooner. Conversely, a rear-heavy car or one with more weight over the back is more likely to oversteer. Engineers adjust suspension angles, tire choices, and weight distribution to control these behaviors. In racing or everyday driving, managing understeer and oversteer is vital for safety and performance. Drivers learn techniques like easing off the throttle, adjusting steering inputs, or braking to keep the car balanced. Automotive engineers design systems like electronic stability control that help prevent loss of control by automatically adjusting brake forces and engine power. Knowing how understeer and oversteer work helps both drivers and engineers improve vehicle handling. It's all about understanding how a car responds during cornering and making sure that response is predictable and safe. This knowledge leads to better vehicle designs, safer roads, and more confident drivers behind the wheel.